Hello, and welcome back to Learning with Lee. In this episode, we are going to continue to take a look at merge sort, pointers, and dynamic memory allocation. To begin with, we're going to take a look at how you would actually return a new array from our merge sort algorithm, so as that we wouldn't have to modify the contents of our original array. And there's certain times in which you don't necessarily want to resort the original contents or whatever you're primarily dealing with, because you might end up having it so that it's either accessible by a key or some other reason why it's sorted by some other value other than what this is sorting by. And we'll get into things that are compound entities and more complex objects that can allow you to have potentially multiple things you could be sorting on. So you might not necessarily want to resort the original array. And the way in which you would do that is actually quite simple for this case here. All that we need to do is we need to create a second temporary array, and we can just call this one our result, since it's going to store the output, or what we're going to return as our result. Then we need to make certain that it also is not null. And technically, one thing you will actually see a lot of stuff in older C++ code is that people will very often just do something like if temp and result, because if you're paying attention, result ends up expanding out to 0. And if you remember back to our discussion on Booleans, 0 represents false, and anything that's non-zero is true. So if these have a non-null or non-zero value, then they will return true when treated as a Boolean. However, null is not always guaranteed to be 0, as that happens to be something dependent on your hardware and architecture. So that's something that, even though it almost always will be 0, it just is better to make this comparison here, and it's a bit clearer and a bit cleaner. Then, down in here, we need to memcopy again from our array on over into our now result array, so that both of our two temporary arrays are actually correctly populated with data. And lastly, rather than using array here, all we have to do is use the result. And this will make certain that we end up with the correct values only being in result and temp, and array will be completely unmodified by these changes that we do within the merge sort algorithm. Then we also need to change its type up here, both its definition here and its declaration in the header files. So we can just copy this, head on over to our header files to make certain that we get this correctly, put that there, and over here. And then what we also have to do in here is return this value, because otherwise it's going to basically say we don't have a return statement, which is an error. And over in here, since right now we don't have a return statement and it's giving us this error here, what we have to then do is just pop on down and return result. And that will actually end up working for us. If I end up building this and running it, you won't be able to see that it's sorted in the alternative sorting, but you can see that the original array, because that's what we're outputting right now, is untouched by that algorithm. If I were to just put over here an int pointer, we can just call this result alt and assign it equal to that, and then we can just, similar to how we have this one here, output it down here and output result alt, then you can see that we'll have both the original array up in this test, as well as then right here, because of the way in which this sort of glitches out, you can see the original array here unsorted, as well as then the correct values stored in the result alt. So there still are a couple of issues though. The first issue is that we have a memory leak right now, because as you'll note, we only are freeing temp, we are not freeing result yet. And we can't free it in here, because otherwise our result down here will be undefined. If I do something such as free result, we're going to wind up with probably our program crashing because it's going to be undefined, and it's going to try to use memory that it shouldn't have access to. So that happens to be a problem. So what we instead have to do is take care of that over in here, and we have to go, I need to free result alt. And that will allow us to then get rid of that memory leak, and have this work correctly so as it actually outputs everything the way it should output it over here with the proper sorting and everything else. Now you might also be thinking, okay, well, why don't we just create an array within here and return that array? So let's just do that real quick. And for this, I'm going to actually make this a bit more complicated than probably it necessarily needs to be, and just going to copy that. I'm going to put that up in here, which we have size defined in isort. And what I then have to do here, well, let's quickly see if this will actually fill it. Yep. So what you see is that right now this doesn't actually see this size that's in isort, and some of that's because I would have to do, and this probably is just using namespace sort. Then if I build this, then it's okay. So that's one thing that we have to deal with. Then over here, if I allow this, to also include isort.hpp, then what I can do is rather than this, I could do something such as, okay, I want to create an array for my result, and we're just going to do this one here, sort size, and then we don't have to use the malloc at all. We don't have to use comparison to null. If I can select it and delete it. We don't have to, well, actually, we still have to do the mem copy, as well as then we can just return this. However, there's going to be a problem, and you might remember when I was discussing scope. And the whole thing about scope is that anything that's declared within a certain scope gets deleted at the end of that scope. And you might be thinking, well, previously you were able to create something with malloc and have a pointer to it within this scope and then use it in the scope out here that ended up doing that. And that's because malloc ends up working a bit differently. It has to deal with the differences between the stack and the heap. The stack gets cleaned up for you automatically when you end up exiting a scope, and stuff that's created on the stack ends up being destroyed. So technically, this pointer here ends up being destroyed when you leave the scope, including the result pointer. However, the address that result is pointing to, which is on the heap, is still valid and hasn't been destroyed and hasn't been touched, so it still has that same data in it, still has been malloced the same. So what we then would have to do over here is, if I build this, what we're going to see is first this warning here, and that is that it's returning the address of a local variable. And the problem that is that, while I was referring to a scope, this is created on the stack. It's not created on the heap. So as soon as we leave here, this is going to give us a problem. But so as I can demonstrate that, let's fix the other problem that we have right now. And that is that right now, because of the fact that both sort ends up defining merge sort alternative, as well as merge sort has a merge sort alternative, we wind up with a problem of it already being defined in a different location. And that's one of the problems that we're having here. So what we can do instead is we can just copy this guy over for now into merge sort.hpp. And that's because right now we were having a bit of a conflict there. So do that. Then over here, get rid of this guy and just replace this namespace with the merge sort namespace. And the only reason why I have to use the namespace even though we're already within the namespace is so as it doesn't end up conflicting with this variable name here. Because right now these have the same name, but by using the namespace to specify that I want the one that's in the most outer namespace, it'll get me this one. It won't end up grabbing this one here, which is being used elsewhere within here. And with that change, that'll fix that, though it will still give us this warning about us returning a local variable. And as you can see then, if I run it, but it's just a warning, so it's not going to stop you from actually running. And the problem is that then it ends up crashing the program. And the reason is that this, as soon as we end up leaving this scope down here, result ends up being cleared and deleted. And that memory is no longer our program's. It no longer is ours until we end up, by some means, requesting the system to give us a certain amount of memory again that would cause us to regain that area of memory. And as such, we no longer have control over what's in there, and we might be accessing stuff that another program might start using. So, it in general is just going to end up crashing your program, and we'll get into some of the different ways in which errors are represented in the future for that. However, that's why we ended up having to do this malloc here. And if I undo a whole bunch of this stuff and return it to how it was before, then we're in decent shape for how it should actually return this. There's one other little thing that I can do to make this a bit more secure, and that's that at present, result might not be null in the event that we end up with temp being null and result is not null. If for whatever reason it was able to not malloc on temp, but was able to malloc on result. And that could be a problem because result would be effectively unsorted, so the only way in order to really represent that right now is just say result equals null in case either of those two is null. We interrupt your regularly scheduled program in order to bring you this note, and that is that what I'm about to suggest is that we assign a null to result down here. And that gives us a certain problem, because we will have a memory leak if we do that, because we will have never freed this pointer here, in the event that result is not null. So what I have to then do is, if result is not null, so I need to actually have this check in here, to make certain that, and you'll see that null pointer is also another option for having it expand out to 0 or to this. So just make certain that's not null, because if you try to free something that's null, that also is a bug and can cause your program to crash. So free result, and then set it equal to null, because otherwise you will wind up with a memory leak if you just set it equal to null and don't do a free. So then over here, we can then also fix this, because we no longer have any need for this size. That can just be gotten rid of. This one here, it can remain there, but we can just get rid of it there and undo a couple things over here. And then down here, put in that, so as we actually have the correct size that we're wanting, and then build it, and it will take us back to how we were originally operating, and it'll work out fine. So you might also be wondering, as a result of this, why is it then that if I want to have something that just ended up returning an int, rather than returning an int pointer or the like, why that would actually work for things such as what we were dealing with earlier, in case I head on over into our square root function. In here, where it's returning a double, and this is returning a double, and you can end up seeing that we end up dealing with things that are effectively local variables. The major thing is that what that error was showing was that we were returning the address of a local variable. So we were returning its spot in memory, not just the fact that it was a local variable by itself. So in this case here, whatever happens to be pointed to by value and by guess, because we're passing in by value, not by reference, basically means that these are effectively local variables that only exist within this scope. However, the fact of the matter is that what the return allows us to do is it allows us to basically take whatever value is being returned and copy it back into some memory that the calling function ends up using. So we can just end up going from like here back to whatever ends up calling it, and in case we just follow it along its thing into I square root and the like, and then this will return that to whatever's calling it. And it, for those that are just doing something like this, where it just is returning the other one, it's effectively using a temporary placeholder and then passing that back. And it's a matter of, it can just copy that value back to the original calling function. However, if I tried to say I want the address of value or guess to be returned, so as that I want the specific spot in memory where that's stored, the fact of the matter is that once we're out of this scope, whatever's in that original spot of memory represented by guess or by value, those no longer happen to actually be accurate for what they happen to be used for by our program. Because it could be overridden by some other function that we're currently using. It could be overridden by a different function. It could be overridden by a completely different program going on your system. Because at that point, we've basically said we no longer need that memory. So, thank you very much for watching. I hope you have a wonderful day.